Welcome back, folks. Some of you may know me from the Restoring Darkness podcast, and others get a grip on lighting, and some both. And of course, I'm here today with the host of the Get a Grip on Lighting podcast as well, Greg Eric, and we're happy to be joined by Mark Baker. He has a Bachelor in Science in Electrical Engineering from the University of California at Santa Barbara, and he is also the founder of the Soft Lights Foundation, which is a 501c3 nonprofit registered in the state of Oregon. It is one of the world's leading advocacy groups for the protection of people from the harms of visible radiation from light emitting diodes and for the protection of the natural night as a resource. So now you know why he's on both shows, Get a Grip on Lighting and Restoring Darkness. Before we get to our interview with Mark Baker, if you have light bulbs in a warehouse and you sell them over a counter, or you take orders on the phone, or you got a website and you sell light bulbs, you should be a member of NAILD. So you do that by going to naild.org, that's nailed.org, and we have a convention coming up, September 17th through 19th in Dallas, Texas, with the ArcLight Summit. That's right. So go to naild.org. Welcome to Restoring Get a Grip on Lighting, Mark Baker.
Well, thanks for having me. I appreciate it.
No problem.
So, Mark, are you telling me you're here to stop the LED train that's been rolling through for the last 7 years?
Well, I would be telling you that.
Why?
Oh my gosh. Well, I think it's unhealthy and it's hazardous to our health. I said the same thing twice there, but I've looked into the regulatory process, and the regulatory process has been skipped. So, may I discuss a little bit about a little bit of history on the regulatory process?
Yeah.
By all means.
Okay, sure. So, one of the, well, going way back, 1946, the federal government passed the Administrative Procedure Act. So, this set up our structure for how the federal government creates new rules, and the federal agencies take petitions. They can do citizen petitions, or they can do their own. Manufacturers can submit petitions, and the federal agency will look at those petitions, and they may create a new rule, they may modify a rule, or they may even repeal a rule. So that structure has been in place. We have regulations.gov where petitions get published. The public can comment on these petitions, and there's lots of stuff behind the scenes to make sure that the rule is good, right? That we're not hurt by the rule, that businesses are successful, that people are successful. So that's how it's supposed to work. Another law that was passed was the 1968 Radiation Control for Health and Safety Act. In the 1900s, when all these electronic devices were being invented, people were getting sick. It was exciting. We had radios, televisions, x-ray machines, but the radiation coming out of these machines, these devices, was unregulated. So people might sit in front of a television right in front, and there was no shielding for the television to make sure that those people were not harmed, typically by radio frequency radiation. In the 1960s, we invented LEDs, we invented lasers. So Congress started to kind of recognize that, wow, some of this radiation is pretty cool. We can do a lot of stuff with it, but it's causing people to be sick. And there were certain incidents that, pushes Congress along. And so, a typical compromise, but it was passed. And so the interesting thing is that the agency that was assigned to regulate electromagnetic radiation from electronic products was the Food and Drug Administration. You might not think that that's the right place, but that's the agency that was given this job. So the law was codified as Statute 21 USC 360 II. And it's not very long, but it directs the FDA to publish performance standards to make sure that the public is comfortable, that they're safe, and that their health is not being impaired. The 360JJ also requires the FDA to submit reports to Congress. What are the impacts of this radiation as things are progressing? Are we keeping on top of it? Keep Congress informed. So that was another law. In the 1970s, there was an oil crisis. And for the first time, the government started to recognize that there was this idea called energy efficiency. So up till then, nobody had ever cared about whether some service was efficient or not. But the oil crisis, the oil embargo of 1973 kind of like woke up Congress. So they started to do stuff, typically with the Department of Energy, to talk about how can we get the same service but using less energy, so we're not as reliant on, let's say, foreign oil. So as they moved forward and started to pass laws related to efficiency in different kinds of, maybe it's vehicles, maybe it's appliances, the light bulb got addressed. So in 2005, the Energy Policy Act was the first time where Congress had become aware of a new technology called light emitting diodes that were high powered LEDs that they could illuminate a room. And they were excited about this idea. And to push it along, they directed the DOE to go and see if they could make a solid state light bulb that was just the same, equivalent to an incandescent light bulb. So that was the directive in that law in 2005. By 2007, everybody had gotten so excited about this idea that solid state technology, LEDs, flat surface chips, could generate this light using, well, they say less energy, but using little energy, that everybody stopped the whole research part and just said, let's do it. Let's move ahead. Let's start making these devices, selling them, pushing the public. They had a program called the ASSIST program from Rensselaer Polytechnic Institute, Lighting Resource Center. They got industry together, DOE, I think even the EPA was supposed to be there. And they said, how do we make this, push this into the public? Problem was that this solid state lighting was not an equivalent to the incandescent light bulb. That part was either ignored or purposely suppressed. And what we ended up with was a different type of radiation. So as time has gone on, and it's been decades already, we have learned that LEDs are a different kind of radiation source. So LEDs are a flat surface. The geometry is different than a typical curved surface. So the radiation comes out in a directed energy beam. It's not just uniform illumination. So the physics characteristics are different. The regulatory structure is different. Everything needs to be different for LEDs. And then the second thing that they forgot was that it was the FDA that was required already back in 1968 to regulate it. So within the DOE, they started this push then, and Congress, nobody told Congress that, hey, this light is really dramatically different. We have spatial properties that are different, spectral properties that are different, temporal properties that are different. We really need to get a handle on it. And we haven't done any studies to make sure this light is safe. Turns out that it's actually quite hazardous. Certain people will suffer seizures, migraines, anxiety, nausea. There's all kinds of neurological impacts and photobiological impacts from this type because it's very intense. And without the regulations from the FDA, it's just a free-for-all. So everything out there, from LED headlights, LED street lights, LED general service lamps, the strobe lights on emergency vehicles, it's all unregulated. So what we're trying to do at the Soft Lights Foundation is to fix that, right? To get the government to understand what happened. The Congress didn't ask for the DOE to deliver some light bulb that was different. They direct the DOE to go deliver the same quality of light as an incandescent, and that didn't happen.
Hmm.
So, you're saying LEDs as a general are all bad right now? Are there any that are okay?
Well, each of us humans has a different sensitivity to the radiation. I personally, there's a right now in my room a soft amber LED light. I'm okay with it. It doesn't seem to bother me. But as you ramp it up to the higher color temperatures, the bluish whites, 4000 Ks, actually for me, starting around 3000 K, 4000 K, certainly 5000 K. LED headlights are 6500 K. So this color temperature with a high blue, I'm very sensitive to. It's an alien light to me. If you strobe it in my eyes, I'm going to have a panic attack. Like I just can't tolerate the high intensity. There are other people that I know that cannot tolerate any LED light. And so if that person is in public spaces and encounters an LED street light or just a regular lamp that has an LED, she's going to suffer a seizure. Well, for her, no LED is probably safe. For me, a soft amber LED, it's okay. I'm fine with that. For others, they don't even notice the difference whatsoever. They can go into a shop, gas station, they seem oblivious to any of the effects. So we have this spread. So it's impossible to say, well, all LEDs are bad for everyone. But we know that there are certain individuals where all LEDs are bad for that certain individual.
Is it a Kelvin temperature thing? Because there's compact fluorescence, there's linear fluorescence that are 6500 Kelvin. Is it just a Kelvin, or is there something more to the LED itself that makes it worse than fluorescent?
Yeah, that's a good question. So, what is not understood and what we're trying to push the government to understand is really, first of all, is the spatial properties. So, everything in nature has a curved surface. So, when the light comes out, it's radiating in all directions and what they call an inverse square law. It's gently dispersing. So, the energy is getting less and less. We know with laser beams, though, that that's not true. A laser beam is close to collimated and it's going to be very intense, whether it's at 1 foot or 100 feet. It's still very dense. So LEDs is similar to lasers. And the reason it's like that is because of the shape of the chip. So if they were able to make a curved chip, even though it's a light emitting diode, a lot of these problems would go away. But on a solid state surface, it's flat. So the geometry causes the light rays to overlap each other and created this directed energy beam. So that the type of source is called a Lambertian source, or you might see flat surface source. But within that beam, it's a mathematical Lambertian cosine. So the energy is very dense in the peak, in the middle of the chip, and then falls off following a cosine law. So I've been in communication with some physicists in the laser industry. It's not we're not 100% sure exactly because I get different people are well they're still studying this stuff, but this one person had told me that 85% of the energy is within 120 degrees. So as it comes out, so most of the energy is in 120-degree beam. But without any regulation, without setting any limits on the peak luminance, I know for sure that LED car headlights are at 70 million candelas per square meter. LED streetlights may be at least at 100,000, maybe 200,000, maybe more candela per square meter, whereas human comfort level is way down at 300 candela per square meter, or they call it nits. So when you buy an LED television, you buy an LED flat screen, monitor, whatever, it's going to be around 300. They have them up at 500, etc. But it starts to get pretty bright. You start to say, wow, that's pretty intense. And so we have these light bulbs and we have these street.
No, you keep going.
streetlights,
I'm just
etc.
telling Greg that I'm going to ask you a question next. So don't worry about when we're
Okay,
doing
okay.
this. I'm not asking you to be quiet. I'm telling Greg I'm talking next. So you go ahead.
Well,
Finish up what you're saying.
I'm a former teacher, so when somebody kind of raised their hand or something, I was used to like, oh, I get you. Um, so it's this lack of regulation is a really serious problem because without the regulation and without the studies, we don't really know the impacts. And since each individual is going to react differently, it's a very difficult problem. So we kind of need to, like in my mind, we got to go back to square one, kind of stop what we're doing, get it all figured out, and then roll it out again if we can, if it's safe, right?
What's it? You're like a voice crying in the wilderness. Um, but you know what? Yeah, I'm inclined to take you seriously, and I'll tell you why. Because the lighting industry has a history of this. Okay, so this wouldn't be the first time that a technology was discovered to cause health problems. Lighting technology, other technologies as well. And also, my anecdotal, so we know for sure that T12 fluorescence caused health problems. It was proven by Dr. Arnold Wilkinson or Wilkerson. Can't remember his name. Episode 6 on
Wilkinson.
Get a Grip on Lighting. So he proved it in a double-blind survey or whatever experiment he did. We know that LED flicker is a serious problem that the industry hasn't addressed. We know that I've talked to numerous sleep experts that tell me that, blue light at certain times of the day disrupts people's circadian rhythms. We know that's true. Um, and we know that people have varying degrees of sensitivity to these problems. And another issue is, the lack of infrared in the light. Um, is that because, that's what's in sunlight is infrared. And so that's missing, and that's in incandescent light as well. And so there's actually reasons, a lot of reasons to take this more seriously than most people are. And so a lot of listeners, what is this guy talking about? He's crazy or whatever. You probably get that a lot. But my question for you would be this. Um, yeah, and actually, I'm going to preface that. I actually have a theater in my house where there's a projector behind us that shines onto a screen. And I'll tell you, it's far more comfortable to watch something on that than it is to watch it on an LED TV. I'm
Yeah.
telling you, like when you sit in front of that theater, it's like, oh, you can actually relax, and you can watch a movie or a show on that theater screen. Whereas on the TV, there's a lot of pressure from the light from that TV that's in our rec room. But in the theater, that pressure is gone. And so I think you're onto something here with the directed nature of the light, the intensity of it, its color temperature, whether or not it has modulation to it, and all these other things that to varying degrees impact humans in a bad way. And I actually think you're right. I don't know what's wrong, but I think there is something wrong, Mark.
Yeah. So this idea of pressure is interesting, and it's accurate. So the energy comes. So the photons have energy. It's coming to your eye. It doesn't just evaporate. There's something happens. There's a
Mm,
transfer of energy when it reaches the cells in your eye. And I feel that when I see the light, the intent, that's why I go insane because it's so much pressure. Not necessarily just, I can look at a computer monitor, no problem. But as it increases and gets more intense, then I'm feeling that pressure and I need it to go away, right? It's
mm.
bothering me so much and we can't relax. And that's the numbers. So let's stay with nits, maybe it's easier to say. So the values where humans are sort of designed for have evolved evolutionarily wise, biologically, is low, like in the so neon light is 8 nits.
You mean true neon, not
Um,
fluorescent. You're talking about neon glass tube.
right, those
Yeah.
neon signs from the 50s or whatever. Yeah, so it's 8 candelas per square meter. That's the density of that light. I can look at neon, no problem, right? So if that's a sort of a comfortable level, And then we start increasing to LED screens at 300, where you're already kind of going, wow, it's pretty bright. Our comfort level is somehow somewhere below 300, even below 100, below 50. We're not, the whole idea with sunlight, you don't really want to look in direct sunlight. You want the light from the sun to reflect off of some object so that you can tell that it's a tree or a tiger or a butterfly, whatever it is. That's how the whole system works. So now we're taking to directing this light from a screen in our car displays directly into our eyes. And it's just uncomfortable and dangerous for many people.
I agree with you on the car displays. I feel exactly the same way. As soon as I got to turn that thing down because there's pressure. That's the only way I can describe it. I feel like there's pressure from the light. And listen, sunlight is something different. I would say that I bet you there isn't a scientist, Greg, that could come on this show that could tell us actually what sunlight is. Like to tell us what it actually is. I don't even think they know. But the other thing you have to remember is that it's filtered through the ozone layer. And it changes color. It's dynamic throughout the day and it doesn't flicker. Okay. And it interacts with your skin in a certain way. Your body knows what it is. I think Mark's making a point that we have to be very careful when we're assuming. I remember we interviewed a fellow, Greg, that said, yeah, what we need to do is bring 5,000 lux indoors and that will mimic the sun. And, it improves people's health. I think
Blast it at you.
yeah, I think
Yeah.
this idea of, listen, and I know we're going down the circadian road with nailed and education and all this sort of stuff. And I got a fake skylight in my producer's office here that looks great. It's changing color right now, actually. And there's all these other great technologies, or maybe not so great. But I think that it may be time to step back from this for a minute and say, listen, electric light is nothing like sunlight. It's something different. Those two things cannot equate to one another. They're not the same thing. And in fact, just because you can see in that light, it doesn't mean that it's carrying with it all of the other things. Incandescent and halogen are probably the closest things we have to sunlight, actually, indoors. Like there's a filament, it's burning. There's actually there's a fire there. I mean, there's another word for that, but there's something burning, and then there's this reflecting. There's like a mixing that happens, Greg. From a parabolic reflector or an MR16 reflector, the light is bashing itself off of that and then comes out of the fixture in like this. I know I'm using a non-technical terms here, Mark and Greg, but it comes out of the fixture kind of mixed, and there's some mixing that happens with LEDs, man. They're pointed right at you, and the best example of these is headlights and the glare from streetlights. And I would say that on the darkness restoring side, if you can see the light source in an outdoor light fixture, that's a bad light fixture. You should not be able to see the source of the light. That's what causes all the glare, Mark. And when I'm driving down the road and you can see like these, you can see the LED array. You can see it from the side, and when you come up to it, I don't think that's healthy. I don't care whether it's flickering, not flickering, what color it is. It's a super bright light source, and I don't think it improves the visual acuity. And I think you may be right. You may be onto some other health problems for some of our brothers and sisters out there, Mark.
Right. So everything you said, I agree with. So, um, a lot of it comes down to it's cheaper to make a street light without the diffusion, without, just throw it up there. There are a lot of myths out there that, oh, somehow this 4000K light will improve the visual acuity. But we have a video. One of my colleagues is Noah Savadier. He lives in Canada. He did an hour-long presentation debunking a lot of these myths that are out there about the safety of, how it improves driving safety. There's a lot of things to consider when you're doing a street light. Contrast, for example, between the dark and the light, the speed of the vehicle, and your rods and your cones in your eyes. They have different functions. We've kind of obliterated the use of our rod cells, which is for low light. We try to sort of turn nighttime into daytime, and it's not working. So actually, pedestrians are harder to see. You probably experienced this if you've walked or driven in a city and there's all these LED headlights pointed directly at you, and then there's LED street lights, and then there's floodlights from stores. If you turn your head to look to see if there's a pedestrian crossing, you can't see the pedestrian, right? It's just all glare. And so there's this misunderstanding about we need to keep the light at human levels. And right now it's out of control.
The there's a reason why a police officer walks up to your car at night and shines a flashlight in your car. That's because so that he or she can see you and and you can't see them. That's the reason why.
Yeah, right.
There's a reason
Right.
why prison guards shine lights directly at prisoners in prison yards because they can see you and you can't see them. So the effect of glare is real. Now, what you're dealing with in these other areas is fractions of that, right? So, yes, the street light's not pointed right in your eyes, but if you can see the array of the light, there is a certain amount of glare there that's going to reduce your visual acuity, the way that your eye focuses and these other things. So these are things to look into. But the other thing is that light kills a lot of things. Okay? There's millions of dead birds because of light. So we know that electric light kills things. Like um this is not new, okay? The whatever that place is in Vegas that shines the light up, or the World Trade Center, they had to shut down those lights because the death was so grotesque, Mark. There was so much bird death, avian death from the lights that they had to shut it down. They can't have it on all the time, right? So we know that electric light can kill things. We know that it can cause damage to all manner of wildlife. And why would we assume that humans are different, Mark?
Right. And there's a lot of these assumptions. So recently there was some dispute between I think the FAA and the FCC regarding interference with some 5G cell phones or something like that. I forget exactly. But they were talking about their fear was interference with the machines, the devices, the electronics. Nobody was talking about the interference with our cells,
Mm.
our nerves. So the passengers in the plane, that's not part of the conversation. It's all about the electronics. In the case of LEDs for so-called energy efficiency, the technology was all the discussion about somehow saving energy and the discussion about the impacts on human health or avian health or insect health. That's been all ignored. So our job has been, well, we've taken it upon ourselves to try and get the government to listen and follow these procedures that I mentioned earlier that exist already. There were federal laws that have not been complied with. All of this kind of could have been avoided if these federal procedures had been followed. The Illuminating Engineering Society published a newsletter in August of 2023, which was the first time I saw a very strong statement about flicker. They actually acknowledged that it has this digital flicker has serious adverse health impacts and that they should get a handle on it. Well, I agree. So that they should, but we also should have gotten a handle on it before we release these things. So flicker for a lot of my colleagues is very devastating. So we have people in our group that have come to me or we found each other because they can't leave the house anymore. So this flicker that's kind of everywhere is causing them to suffer, let's say, a migraine for a week at a time. So they have to have their husbands or their spouses drive them around, go grocery shopping. They can no longer go to work. That's pretty serious. Um, we've tried to get the disability angle. We've tried to contact in America the U.S. Access Board. We've contacted the Department of Justice. We've also contacted these same sort of agencies in Australia and New Zealand and the United Kingdom, and they're not listening. So they kind of write these people off as like their lives are not that important. That somehow saving energy is the most important thing. And we feel that, well, no, it's great to save energy, but humans and our brothers and sisters in the animal kingdom are the most important.
Going back to kind of what you said, what I think maybe was a major issue is the fact that LEDs are flat. Can you make them curved? It looks like in a little bit of bio. You have a primer on the differences between a curved surface emitter and a flat surface emitter. What is that all about?
Well, the primer was to try to explain to people that there's this major difference in the light quality in a curved surface versus a flat surface. To make human compatible light, it needs to be curved. I don't know much about organic light emitting diodes, but my understanding is that they can actually be curved. So um, solid state, the stuff that we use today with the silicon, as far as I understand it, they're not able to curve it. So it's flat. So for the purpose of making a little indicator light, that's great. But for the purpose of illuminating a room, illuminating any kind of volume of space for headlights, this is a terrible technology. If they could design OLEDs and curve it, then yeah, then you could control the light the way you wanted to, get the spectral output the way you want it to, get the flicker the way it should be. Yeah, it'd be neat if you could control it that way. Um, I lost my train of thought there. So
Just
go
curved
ahead.
LEDs. Yeah,
Yeah,
yeah.
yeah.
I guess
So IES has acknowledged, 2.5 years after Get a Grip on Lighting, did a whole bunch of podcasts on Flickr. That's okay. They can be late to the party.
Is that
Um,
right?
yeah, it's okay. Everyone's already drunk. But yeah, sure, come on in. Um, but let me, what this whole DOE business that recently came out, state of the art 2007 legislation. Very upsetting to people that sell light bulbs every day that know the challenges related
Hmm,
to this, specifically just simply from, you know, functioning existing systems like Greg's story recently about the theater and myriad of applications where,
right.
you're just going to destroy the ability of a theater to create the effects it needs to create for people to enjoy a show. Um, from your perspective, how do you feel about the DOE's recent foray into destroy all incandescent light bulbs, send them to the recycling factory? How do you feel about that?
Well, I am so upset that I have contacted the Department of Energy Office of Inspector General, and I have let them know how upset I am. And they have agreed just recently to open an investigation. I call it fraud. I think that the people that I've talked to, I think that they understood the health impacts. I think they understood how this light works. I think that they saw an opportunity to make money with the industry and to, sort of do this green thing make members of Congress happy. But what they didn't do is let Congress know the truth. So we have case number 23-0319-C that's been opened up in the DOE OIG. If they do their job, then I would expect that they would find quite a bit of problems. I recently, one of my colleagues sent me some information. DOE did not follow the National Environmental Protection Act when they did the 45 lumen per watt uh, backstop rule. So when they did that, they did what's called a categorical exclusion. They simply said, we don't believe that this light or this rule will have any impact on the environment and no impact on human health, and therefore we don't need to do any kind of a study to see. We'll just call it, it's such a small, minor, little change that we'll just call it a categorical exclusion. Well, that's ridiculous. Of course they need to do a study. That NEPA was written like 1970. It's been around a long time, but they didn't want to do it. So that's part of my submission to the DOE OIG. They didn't comply with NEPA. The fact that the DOE, so the statute 21 USC 360 II mandates that the FDA collaborate or liaise with other federal agencies. Okay, now that means the DOE. What I've done is contacted all these federal agencies and say, hey, you're not complying with this statute. And they've all written back to me and said, well, that's not our job. That's the job of the FDA. If the FDA contacts us, sure, we'll talk to them. But we're not going to reach out to the FDA. Well, that's also ridiculous. So the DOE has not communicated with the FDA on this. So the DOE has published this 45 lumen per watt rule, which, by the way, is not an energy efficiency rule. It's only a luminous efficacy rule. And if you want, I can talk to you about that. So, and so the FDA hasn't done their job. And so there's no performance standards. So the DOE has made this rule, which has banned a perfectly safe incandescent light bulb, which nobody was really having any problems with. And now people who cannot neurologically tolerate this LED light or its impact on the environment or whatever, were being forced to buy this hazardous products. And of course, if you look at the whole process and you look at the supply chain and where these materials come from and all that other stuff, I'm not so sure that there's any savings at all. It's just a complex technology that makes a hazardous light. So no, I'm not happy with the DOE.
I had a woman come into my counter here and buy every single 25-watt chandelier bulb I had. Okay. Um,
Yeah.
and she was very upset. Now they're not. It's not happening in Canada yet, but Canada usually follows whatever the United States does. So she wanted to make sure that she was able to have all of her lights incandescent forever. Um, the What's interesting to me on this is it's there. You know, this is not a freedom issue. It's not like people have the right to use more energy or less energy or anything like that. It's To me, it just doesn't seem that far fetched that some people might be negatively impacted on this and that this is totally unnecessary for dozens of reasons. One of which is that a certain percentage of the population has claimed that this technology hurts them and acutely. Maybe it hurts everyone chronically, we don't know, but it hurts them acutely. And so to make this rule, I think, is entirely irresponsible for a ton of reasons, but particularly that one, Mark. And, can they reverse it? Can they turn back? What would happen?
Oh, yeah. Right. So it's very difficult to turn back. There's when you read the media articles and stuff, they use words like, modern technology, improved technology. It's very difficult now to convince people that, well, actually, it's just different technology that's actually worse, and it doesn't meet the um, statements made by government officials, by industry people, that it doesn't meet those things. May I speak to you a little bit about energy efficiency?
By all means.
Okay. One of the things that we're trying to communicate and get people to understand is the difference between energy efficiency, which is the common word, and luminous efficacy. Unfortunately, they're similar words. Luminous efficacy is the number of lumens per watt. So the whole goal has been to increase how much light comes out per watt of energy. And that's a fine goal, but that's not energy efficiency. Energy efficiency, by definition, is providing the same service using less energy. You're not allowed to reduce the quality and call it an energy efficient light. And that's exactly what's happened.
Yeah, like the
You
dishwasher,
guys know.
you have to run 3 times to get your dishes clean because it doesn't use enough water or something like that. Like, I'm not kidding with you. I bought an old dishwasher from 30 years ago, okay, and I put it in my house during a renovation because I didn't want to buy a brand new one. That dishwasher worked amazing, buddy. It washed everything, every scrap off every dish. Now, was it as efficient as the other one? No, but it worked better. I couldn't agree with you more. I think what energy efficiency is like this cloak word for bad quality a lot of times, or not as good, or not working as good. It's the same thing with front loading washers. Like, why are we following these Europeans that have no water? When I look out over here, I see these enormous lakes full of water, fresh water. I don't mean to say we shouldn't save water, but I mean to claim that Ontario has a water problem. Well, if Ontario has a shortage of water, I mean, there's the world's got bigger problems because Ontario has more fresh water than anywhere else. So all this energy efficiency, I agree with you. I think it's cloaking some other things, but I have a trouble seeing. I like To me, this is just complete incompetence. I don't see anybody like the industry lobbying. Greg, do you feel like the lighting industry has a lobby in Washington to try to make these incandescents illegal? I think most people in the lighting industry, at least at our end of the lighting industry, would say that's a stupid idea. Why would you do
Mhm.
that, Greg? What do you? I
Right.
mean, I don't see like a lot of times, you see that there's a clear beneficiary to some policy the FDA makes, and I don't want to get into what happened recently. in the world, okay? But sometimes you see that there's a clear beneficiary, okay, to whatever the policy happens to be of the day. To this one, Greg, I can't see the lighting industry, somebody down in Washington lobbying. Who's lobbying, Greg? I don't know.
I don't think there is anybody, and that's what a big reason we have this podcast and we have these talks is hopefully maybe someday we can get somebody to do it, and Mark, I guess that's what you're fighting for, and my question to you would be, all right, Mark, the lighting gods say you're in charge now. Go for it, Mark. What do you do? What do you do right now, Mark?
Oh my
Give
God.
it to us. What do we do?
Do I celebrate or do I just panic?
I don't know.
Don't know.
Um,
You're in
yeah,
charge.
I,
It's all
I
you.
certainly would have, I certainly could be in charge, and I would prioritize health, you know, and I would prioritize honesty, and I would stop, existing things. Um, right now, I'm always got different things going, but LED strobe lights are sort of a simpler problem to solve. So you may have seen in the news recently, Waymo and Cruise robo taxis crashing into fire trucks in San Francisco. So the California Public Utilities Commission authorized these robo taxis, and they're crashing into. They're also going into wet cement. But one of the things they crash into is emergency vehicles. Well, emergency vehicles have these LED strobe lights on them. Again, unregulated, not FDA approved. Nobody vetted these, and they're just impairing everybody's vision. And so artificial intelligence systems can't see through this light either. So
Hmm.
I spoke to an assembly member staffer today, and I said, "Hey, sort of like you're saying, like if I was in charge, so could you connect me to the California Department of Motor Vehicles and connect me to Waymo and connect me to Cruise and stuff?" And we get all these people together, and what I would tell them is the engineers are smart, the physicists are super smart, they can figure out all kinds of stuff. But if the light's too intense, there's just they can't solve the problem. But you can solve the problem by getting rid of the problem that was sort of self-inflicted wound here. Ban the strobing lights.
I
It doesn't
don't. I
help
don't know how
anybody.
police officers take that. When you're
It's
when their lights are on and at the side of a road, it is disgusting. Like I feel like I'm gonna vomit when I look at them. Like how bright and they're going crazy. I couldn't agree with you more. What a disaster those are. I mean, imagine if you had to deal with that all day as a police officer. I mean, the police officers union should be doing this.
And
But
so we've contacted the police officers unions. We've contacted city polices, and everybody's like shrugs their shoulders. They're waiting for somebody else to solve it. So, Greg, if you put me in charge, that would be great because I would solve it.
There you go.
If you have that power, let's go ahead.
I think it's actually I like to one of the things that I think a lot of people don't understand about institutions, okay, is that institutions are designed to resist change. Okay, so
Mhm.
the Catholic Church being the oldest, right, does built so that it can resist change. Um, but what happens is when these people start to step out and they make decisions, it's almost impossible for them to admit they're wrong. And it has nothing to do with integrity, it has to do with the structure of the way the institution works. And once they decide something, they move in that direction like a horse with blinders on. And they can't change. It's very, very difficult for them to step back and say, like, is anyone going to stand up at the DOE if someone doesn't get fired and say, you know what, we were just joking? Joke. I know it's not April Fool's Day, but yeah, we were just joking. You don't have to destroy all your stock and the $542 a light bulb fine. That was just a joke. And we don't even know how we're going to enforce it anyway, right? Like this is the kind of thing that, you see. But I know what I would do if you put me in charge. First thing, number one, the lighting industry has to focus 100% on the restoration of darkness and the preservation of night when it comes to exterior lighting. 100%. That will capture everything else. You'll get all the energy efficiency. You'll stop killing birds. You'll deploy lighting controls in a really effective way. All sorts of great things will happen if you make that the single goal for exterior lighting. In interior lighting, I would say, number one goal is not to have to cause people to do renovations. And so every time a light bulb burns out. So right now we have a situation where every time a light fixture burns out, Greg, you got to replace the whole light fixture, right?
Right.
Right. I would dictate that
I
all light fixtures have to come with replaceable. They have to be industry standard replaceable parts that can be made to replace those cross manufacturer. And within 5 years, all manufacturers have to comply with these standards so that people can repair their light fixtures without having to rip them out. And so those would be my
Michael,
two priorities.
I that would be great because I just went through that in my house. So we purchased this house a few months ago. It came in the kitchen with LED lights, 5000K, right? Now I'm no contractor or anything. So I said, okay, I can't turn on the light switch, right? So I need to change it out. So you open it up, it's not a bulb. I can't screw in a new bulb. I can't go to the store and put in a softer bulb. It's an LED. Well, what does that mean? That means I could have hired somebody, I suppose, but I said, all I want to do is change the light bulb, which I
Mm-hmm.
used to be able to do ever since I was born, is just
Mm-hmm.
change the light bulb. Instead, I had to go on YouTube so many times to learn how to be a construction person, to learn how to, and I had to go to the hardware store and buy all kinds of tools, and I had to learn how to rip stuff out of beams and buy these boxes and do all these kinds of things that contract professionals. And I'm impressed with professional contractors that do this for a living because every single thing I ran into was like another roadblock for me.
Mm-hmm.
Like nothing worked right. So it took me an entire week to change the light bulb in my house.
Yeah,
That's
and
not right.
so and then to the lighting industry, I would say this: forget about you know improving human health. Stop damaging it. Let's start with that. How about we stop damaging human health? Stop killing birds. Stop all these other things that were or all manner of wildlife and shining lights into the ocean 2 miles out into the sea and causing all manner of problems. Why don't we start by not damaging things? And then once we've eliminated all the ways in which we damage things, then we can start talking about productivity improvements with light, electric light. It sounds extremely cocky for the industry to, Greg, to be talking in those terms when there's just so much damage that needs to be mitigated, especially in the exterior. Mark, any final thoughts for the Restoring Darkness and Get a Grip on Lighting listeners?
Well, first of all, thanks for having me on. I appreciate this opportunity to speak about this stuff. Um, we're working to convince members of Congress. We did get Congressman Michael Thompson of California to send a letter to the FDA, and he's the first member of Congress to use the words or recognize that the FDA is the agency that regulates LED products. Now, I wasn't able to convince him to send a letter for all LED products because he's convinced that LEDs save energy. But what did bother him was LED car headlights. So he said, "Yeah, I don't like those either." So
That's
he sent a
obvious to
letter to
anyone
the
that's looked in their rearview mirror. That those are a problem. Sorry to interrupt you, but yes.
yeah, sure, right. And so you can go anywhere. I agree with you. I don't think you can find anybody say, "Oh, I love LED car headlights." No.
Yeah, that's what I'm saying. It's obvious to
And,
anybody that looks in their rearview mirror that these headlights are a problem. Totally.
and so it's the same lack of regulation across all uses of LEDs. The lack of regulation or restriction on peak luminance, the lack of regulation on dispersion characteristics, spatial uniformity, spectral power distribution, digital flicker, pulse width modulation in some cases, flashing characteristics. So all of that's unregulated. We need that. But Congressman Thompson has done that. It's a step. It's a small step, but it's useful. Um, we've got other people that are contacting members of Congress. I have typically every week or two a meeting like this where we talk with a staffer for a member of Congress, try to convince them to open up an investigation with the General Accountability Office or directly from the FDA, get them to comply with 21 USC 360JJ and submit these reports. What's going on with this LED radiation? Is everybody okay? You should be submitting a report. If they're not okay, then what are you doing about it? Also, we submitted a petition on June 13th, 2022 to compel the FDA to comply with the regulations. And we just recently learned, it's not official, I just heard it through back channels, but they held a meeting with laser specialists on July 31st, 2023. So they had people from the laser industry that are experts on light came in and talked to them. Now that should make your skin crawl, because why are they talking to laser specialists about light bulbs, right? Yeah,
Right.
because it's that hazardous. So so the FDA is aware, and so we just need some pressure from somewhere. And if the industry, the lighting industry, would say, "Wow, actually, I don't know, we've sold all the LED bulbs we can. We'd love the opportunity to go back and sell everybody incandescents again. Everybody makes more money, and everybody's healthier again."
Well, you couldn't find a fixture to put them into anyway. So
No,
go.
that's the problem now, right?
You can find Mark on Facebook, um, softlights.org. Pretty simple to spell. I don't have to spell it out for you guys. He's also got a petition on change.org. It will all be listed on the Get a Grip on Lighting and Restoring Darkness websites. So if you want to go there to find that stuff. And, hey, just to preface something I said earlier, all you researchers out there, keep researching. What I'm talking about is the practitioners in the field that go around, Greg, talking about productivity improvements and all this kind of thing. Give me a break, buddy. Get a grip. Get a grip on that. Come on. And, folks, if you have light in a warehouse and you sell them over a counter, you take orders on the phone, on a website, or whatever, and you're shipping light bulbs around, consider joining NAILD, National Association of Innovative Lighting Distributors. That's NAILD.org. We got a convention coming up, Greg.
That's right. Be ready for it. Get there.
September 17th through 19th. Thanks for listening. Bye for now.